Okay. Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, कल वाले सेशन में हम लोगों ने डिस्कस किया था simple linear regression. In today's session, we are going to discuss the basics of multiple linear regression. Please try to understand multiple linear regression has so many things associated with this particular concept. So I have divided the concept of multiple linear regression into 2-3 parts. So in today's session, I'll just give you the basic of multiple linear regression, that what do I mean by multiple linear regression and what are the basic assumptions which we are taking when we are trying to understand the concept of multiple linear regression. So this is the brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. This is the Telegram group. If you guys have any doubt related to GATE exam, whether it is CS paper or DA paper, you can ask me at this particular group. I'll be happy to answer. Okay, so see guys, test series is a very important part if you are preparing for the GATE exam sincerely. So this is just the outlook of the test series platform of BYJU'S exam prep. You can also participate in the test series at the BYJU'S exam prep. You can download the application, BYJU'S exam prep application, using the link. The link is available in the description. You can simply download it using that particular link. Okay, so today we are going to understand the concept of multiple linear regression. Yesterday we have already discussed the concept of simple linear regression. What happened in the simple linear regression? There were only two variables. One is independent variable, another is dependent variable. Dependent variable will depend on the value of this independent variable. This is basically the equation for the simple linear regression. So beta 0 and beta 1 are the coefficient of beta 0 is the intercept and beta 1 is the coefficient which we need to identify based on the concept of minimizing this particular error factor E, right? So what will happen in the multiple linear regression? In multiple linear regression, as the name itself suggests, that there will be multiple independent variable. On all those multiple independent variable, one dependent variable will depend, right? So what's the idea? You can have multiple variables. Let's assume that x1 is one variable, x2 is another variable, x3 is another variable, x4 is another variable. So all of them are independent. All of them are independent. And there will be exactly one dependent variable, y. So this is your dependent variable. So what we'll try to analyze here, that we'll eventually use two or more independent variables to predict the outcome of a dependent variable. So we'll choose two or more. The technique enables the analyst to determine the variation of the model and the relative contribution. So please try to understand, when we say multiple linear regression, then please try to understand that this dependent variable need not depend on all these different independent variables in the similar manner. So it may be possible that the output is more correlated with x4 and x3, but your dependent variable y is not that much correlated with the independent variables x1 and x2. So accordingly, we'll have to analyze the weights of this independent variables. Clear? Getting the idea? So there are some assumptions. For the multiple linear regression. What are those assumptions? The first thing is the independent and dependent variables are linearly related. So please try to understand, when I say independent and dependent variables are linearly related, what does it mean? That if we try to analyze the scatter plot of variable x1 with this dependent variable y1, so please let's try to understand that if I do in this particular manner, let's come here, that if I try to draw a plot, that if I take variable x1, if I try to vary x1 here and we try to analyze the value of y, then the variation should be linear. Similarly, if I try to analyze the variation of y with respect to x2, then also it should be linear, right? So what does it mean? So linear means if I can actually draw something like this, right? So all, see, please, you can actually understand one concept, that when we change the value of x1 by 1 unit, then the change in value of y will be different. When we change x2 by 1 unit, then the change in y will be different. It means that y is linearly dependent with x2, y is linearly dependent with x1, but the correlation is different. That, so basically you can understand that y may be more correlated with the change in x1, y may be less correlated with the change in x2. Got the idea? But it should be linearly dependent. So independent and dependent variables are linearly related. It is the first assumption. It should not happen that if I take a third variable x3, let's assume if I take a third variable x3 and y, then it happens something like this. It should not happen, because this is not a linear dependence. It's basically non-linear. It's basically non-linear. Got? Behaves like linear regression. Yeah, I mean, independent variables should behave like linear regression. Let's see, please try to understand. The linear dependence means, that's why we defined simple linear regression model. That is the reason we defined simple linear regression model, because the change in dependent variable with respect to independent variable was linear. It was following a linear pattern. Okay, so that's the first assumption. Yeah. There is, please try to understand, the dependent variable should be linearly dependent. Dependent variable should be linearly related with the independent variable. But another thing is that there is no strong correlation between the independent variables. What do I mean when I say that there is no strong correlation between independent variables? Please try to understand. If I take this 4 variables, x1, x2, x3, x4, and this is my dependent variable, it may be possible that y is strongly correlated with x4, y is strongly correlated with x3, and these two independent variables x3 and x4 may also be strongly correlated. So if there are multiple independent variables, please try to understand, if there are multiple independent variables which are strongly correlated with each other, then we will not use all of them. We will not use all of them. Strongly correlated, if strongly correlated, then we will use only one of them. For regression, then we will use only one of them for regression. Yeah, I mean, that's right. x1 and x2 should not be. So rather than x1 and x2, I am saying x3 and x4 should not be correlated, right? So no strong correlation should hold between independent variables. It is known as multicollinearity. It is known as what? No. Multicollinearity. Clear? Now, that's something which, see, please try to understand. As of now, I am not trying to dive into the concepts of statistics, but yesterday also when we discussed the concept of simple linear regression, then also this particular assumption was there, that your error should have a constant variance. Your error should have a constant variance, and the error should be normally distributed, means mean should be 0 and it should have a constant variance. So the same thing will be applicable in case of multiple linear regression also. What does it say? that your error should have a constant variance. The variance must be constant. And another analysis or another assumption is that observation, if you are taking the different observations, so value of x1 is something, x2 is something, x3 is something, and x4 is something. So this is one observation. So this is first observation, right? We may have another observation. So second observation. So the observations should be independent of one another. So the outcome of this second observation or the second observation should not be anyhow dependent on this first observation. Clear? So these are 4 assumptions. There are some other assumptions, but these are simple to understand. So I'm just talking about this 4. As we'll move ahead in this particular course, we'll keep discussing more and more things, right? But as of now, as we all are just beginning the course of machine learning, we don't want to go in too much detail of jargon terms. So anyway, so that's okay. Let me clear this for time being. Okay. Now please try to understand that for simple linear regression, what is the equation? For the simple linear regression, the equation is that y equals to beta 0 plus beta 1 x plus epsilon, right? And based on the observed data, we estimated beta 0 cap, beta 1 cap, this or beta 0 and beta 1 such that squared error is minimized. Right? That's what we did in the last class. What did we do for this particular purpose? We had the sum of squared error. And then we partially differentiated it with respect to beta 0 and beta 1. And then there were 2 equations with 2 variables, beta 0 and beta 1. We solved those 2 equations and we got the value of beta 0 and beta 1 such that the sum of squared error is minimum. Yes or no? Yes or no? That's the logic. Now, in multiple linear regression, so this is with respect to simple linear regression. Now, let's assume there are k, let's assume k independent variable with respect to multiple linear regression. So if there are k independent variables, therefore the equation for multiple linear regression becomes what it will be. So the predicted value of y, that is y predicted, so it is nothing but predicted, or let me denote it using a new symbol just for ease of understanding. Let me not write it y, but simply let me say y hat. Let's assume y hat is the predicted dependent variable. What will it be? So y hat will be nothing but beta 0. This is the intercept. Now, when I say beta 1 x1, so the weight, beta 1 is actually the weight, beta 1 is actually the weight with respect to independent variable x1. That if we change x1 by 1 unit, how much change should be there in y hat with respect to the change of 1 unit in the variable x1. Similarly, beta 2 x2 and so on. How many independent variables are there? So there are k independent variables. So you will have beta p xp. So this is the weight with respect to variable p and this error term epsilon. So this will become the predicted value x1, x2, x3 are nothing but the observation. So these are the independent variables. Now what is required? So from here the similar concept will be done. Similar concept will be used. See, there are multiple ways of performing the simple linear regression, multiple ways of performing the multiple linear regression, but currently we are only trying to focus on minimizing the sum of squared error. So similar concept is, how can I define the error? So the error term epsilon can be defined as y hat. This is the HC. Please try to understand here. This is the value. This is the value which we have observed, right? So this is basically y hat. Just 1 minute. This epsilon will not be there. So that's the actual value. So we are predicting this as a value. It is the predicted value. So predicted value will depend only on this. Now there will be an error term if we define with respect to actual value. Let's assume that if y is the true output. So this y is the true output with respect to variables x1, x2, x3 up to xp, then what will happen? Sir, this will eventually vary beta 0 plus beta 1 x1 plus beta 2 x2 and so on up to beta p xp. So this is the true output. This is actually your predicted output. This is your true output. This is the predicted output. Right? So if we add this variance with this predicted output, then it becomes equal to the true output. So this is your error term. Yes or no? Is this clear? Here I have defined it as a predicted dependent variable. So predicted dependent variable will be only this much. So what is the variation of predicted output with respect to original output will define your error term? Clear? So what will be error term? So error is actually nothing but y minus beta 0 plus beta 1 x1 plus beta 2 x2 and so on up to beta p xp. Now if I try to define, so this will be one thing, please try to understand. This is just one simple equation with respect to variables, but the idea is that there will be, let's assume that there are n, observations. So we can eventually define as a sum of squared error as what? Sum of squared error can be defined as that with respect to I varying from 1 to n. Please try to understand this. That please look at this. This is the let's assume I varying from one observation. So this is the first observation. So this is the value of x1i, x2, or x1i, x2i, x3i, x4i. So this is nothing but x11, x21, x31, x41. This will be x12, x22, x33, x32, x42, etc. Clear? Are you getting the idea that there will be number of observations? So these are just the independent variable. In the yesterday's case, when I was writing xi, then this xi was actually giving me one information, that with respect to ith observation, what is the input, and yi was giving me the actual y was the output in the original data set, but y minus beta 0 plus beta 1 xi was giving me the error. Clear? So in the yesterday's case, this I was eventually trying to define the observation. In the yesterday's case, this I was defining the observation number, that is which particular observation is being treated. But here x1, x2, x3 up to x4 are actually defining the variables, independent variables. Therefore, don't get confused, and please try to understand that if I write it, beta 0 will be fixed, beta 0 will be fixed. So it will be nothing but yi. What does it mean? What is the actual output y with respect to ith observation? Minus this will be beta 0, it will be fixed for all of them, plus beta 1 x1i plus beta 2 x2i, and so on up to beta p xpi. Any problem with this? So this is your error term. This is the, so if you think of this, that this is actually y1 minus beta 0 plus beta 1 x11 plus beta 2 x21, so beta p xp1. So this is actually nothing but the error with respect to first observation. This is the error with respect to first observation. Yes or no? This is the error with respect to first observation. Yes or no? Please tell me. Is it clear to everybody that when I am writing y1 minus beta 0 plus beta 1 x11, beta 2 x21, beta p up to beta p xp1, then this is the predicted value with respect to, this is the predicted value with respect to the first observation, and this is the actual value with respect to first observation. Clear? But obviously, we are trying to define the sum of squared error. Therefore, for this error, we will perform the square of this. Sum of squared error. Clear? Now what will happen? With respect to this sum of squared error, we can differentiate it. We can partially differentiate it with respect to beta 0, beta 1, beta 2. And how many equations will be there? We can partially differentiate sum of squared error with respect to beta 0, beta 1, beta 2 up to beta p. So, and we will get p plus, what happened? How many observations were there? With respect to k independent variables. So let's please let me write it p. let me write it P because I have used this suffix as P. I have used this suffix as P. So these are the independent variables. First independent variable, second independent variable, and this is the pth independent variable. So there are P independent variables. Sorry guys. Sorry. Is it clear? Is it okay? Is it okay? I just use the suffix P. I just use this suffix P, and here I have written that let there are P independent variables here. Let there are K independent variables. So if I'm writing K independent variables, then this will be XK. This will be XK. But if I went up to XP, then there will be P independent variables. There will be P independent variables. Yes or no? Nobody asked with respect to this. If there are P independent variables, then this is x1, this is x2 up to xp. Please tell me, is it okay for everybody? It's not K, it's P independent variables. So I don't want to change at all this place, therefore I've just said let there are P independent variables. Okay. So now what will happen? If we can partially differentiate the sum of squared error with respect to this, and we will get P plus 1 equations with P plus 1 variables. What are the variables? P plus 1 variables are beta 0, beta 1, beta 2, beta up to beta P. Yes, we will get P plus 1 equations with P plus 1 variables. And I hope you understand that if there are P plus 1 variables and P plus 1 equations, then you can eventually solve those particular P plus 1 equations using the concept of matrices. So that's where the concept of matrices can be used with the concept of linear regression. Yes? So, what did I say? On solving those P plus 1 equations, we will get beta 0 hat, beta 1 hat, beta 2 hat up to beta P hat, which are the estimated values or which are the estimated coefficient such that the error is minimized. Such that the error is minimized. Yes or no? Please try to understand this. Just as I told you that multiple linear regression is not a single step concept. We have just given the basic based on the concept of simple linear regression, that we know what will be error with respect to simple linear regression. Similarly, we tried to define. So please try to understand. It will be a line. But when there are multiple independent variables, it will be a plane. It will be a plane. Clear? So this will be a p-dimensional plane. Because you just need to understand that with respect to x1, the value of y will vary differently. With respect to x2, the value of y will vary differently. With respect to xp, the value of y will vary differently in the different planes. Clear? So it's basically a plane. It's a p-dimensional plane if you eventually try to visualize this in the context of vector space. Clear? But anyway, so simple concept is that we are just trying to minimize the error. We are just trying to minimize the error. So we can just calculate the error with respect to individual observations. We can just calculate the errors with respect to individual observations, and then we can simply square those errors and add them up to minimize the sum of squared error. to minimize the sum of squared error. Please try to understand what you will feel that as we increase the number of independent variables, the predicted value of y should become more and more correct. Yes or no? Yes or no? That's generally a person will think that if y is dependent on those many things, then if we consider all those independent variables in order to predict the value of y, then it will be more appropriate. But the actual idea is that all the y may not be correlated with all these independent variables in the similar manner. Therefore, as you increase the number of independent variables, if you are assuming that your prediction will become more and more accurate, then it may not happen. This will eventually correspond to a concept of overfitting. So just I told you that this okay. So for today's session, let us keep it short and simple. That yeah, just like simple linear regression, we can also try to minimize the error. In the multiple linear regression. In the tomorrow's class, I will try to explain the concept of ridge and lasso regression, which will eventually try to tell you that if there are multiple independent variables, then this may actually correspond to overfitting, and in order to deviate from that particular overfitting, we may need to take some other actions. Clear? We may need to take some other actions. So that we'll understand in the upcoming session. But is this clear? That yes, we can eventually define the error function in context of multiple linear regression also, and in order to obtain the estimated values of beta 0, beta 1, beta 2 up to beta p such that the error is minimized, the concept is quite simple, that after identifying the equation of sum of squared error, we just need to partially differentiate it with respect to beta 0, beta 1, beta 2 up to beta p. We will get p plus 1 equations corresponding to p plus 1 variables. We just need to solve those p plus 1 equations. We will get the values of those p plus 1 variables, and those values are nothing but the estimated values of beta 0, beta 1, beta 2 up to beta p such that the error is minimized. Clear? Don't make it complicated as of now, because our session cannot be too lengthy, so I cannot include all the things in a single session. But yes, in the tomorrow session we will try to revisit this concept, and then we'll try to analyze that how things may vary if there are multiple independent variables. Clear? Any doubt in this? So when we are saying we can partially differentiate the sum of squared error with respect to this, and we will get p plus 1 equation with p plus 1 variables, you can also say on equating them with 0. Obviously, because we are trying to minimize the error, therefore after partially differentiating it, we'll equate it to 0. Sir, can you give some reasoning? What are you, your last term is not visible. Can you give some question related to this? See, there is a very simple concept here. So, okay, I'll share the question on the Telegram group. Is it okay? I'll share the question on the Telegram group. As of now, I'll have to think of the question. So, I'll just share the question on the Telegram group. and I'll also discuss the solution of that particular question in the tomorrow's class if you want to analyze that how the values of beta 0, beta 1 and multiple coefficients can be determined. Clear? So anyway, so this is just the simple concept. We will try to add some more things in the concept of multiple linear regression in the tomorrow's class. But for now, we just need to analyze that yes, just like simple linear regression, my dependent variable may depend on more than one independent variables. Clear? So please try to understand that if this is one independent variable, if this is this is the first independent variable, if this is another independent variable, this is another independent variable, this is another independent variable, and let's assume that this is your dependent variable. Let's assume that this is your dependent variable. So what actually happens that this dependent variable will depend on this independent variable as well as on this independent variable as well as on this independent variable as well as on this independent variable. So the relationship become many to one. The relationship become many to one. In simple linear regression, the relationship is 1 to 1. In simple linear regression, the relationship is 1 to 1. But in multiple linear regression, the relationship become many to 1. But the another problem which you need to understand is that this independent variables may form some relationship among each other. This independent variables may form some relationship among each other. Yes or no? So because of this independent variable, so the number of relationship will increase, and based on that, the outcome of the dependent variable may not be correct. The outcome of the dependent variable may not be appropriate. So we also need to understand, we also need to address this particular concept that if there are multiple variables, then how do we identify that what independent variable should be considered for the regression and what are all the independent variables which can be left while trying to solve the regression problem. Clear? So just like I told, let's try to understand a simple example. Let's try to understand a simple example. If I try to predict the time traveled based on an analysis in which I'm saying that okay, this is the distance covered another aspect. So let's try to understand that this example is actually related, but sir, we had taken assumptions that they are not related. Yeah, so that's an assumption. Trying to understand, we are assuming that they are not related, but when there are multiple observations available to you, you actually need to know that what are the variables which should be considered in order to solve the regression problem, and for that purpose this analysis is also required. So this is just an assumption. This is just an assumption that you are saying that there is no strong correlation between the independent variables. There is no strong correlation between the independent variables. But the problem is that what if there is a strong correlation between the independent variables, and how do you analyze that particular strong correlation? Getting the idea, Panto? The assumption is that there should not be any strong correlation between the independent variables, but what will you do, or how will you identify that whether there is any strong correlation between independent variables or not? Getting the idea? So that's what I'm trying to specify here, that let's assume that this is an example in which there is a delivery system of your meals. So a particular distance covered, that if you cover this much distance, and you also have the number of items delivered and you have gas consumed. So do you realize one thing, that okay, that's fine, that all this three variables are independent variables, and on this three independent variables the time traveled will eventually depend. Yes or no? The time traveled will depend. But do you realize that distance covered will eventually be in the strong correlation with the gas consumed? Yes or no? The distance traveled will be in the strong correlation with the gas consumed. So if you have consumed more gas, or if you have consumed more fuel, then ultimately you have covered more distance, and if you have covered more distance, if you have consumed more gas, then the time which will be required in order to travel that particular distance will be more. Yes or no? Yes or no? So if, please try to understand, if you try to plot the scattered, if you try to plot the graph between gas consumed and distance covered, then you will eventually realize that gas consumed and distance covered are highly correlated with each other. The number of items delivered may or may not be highly correlated with these two particular factors, because maybe the person to whom you are trying to deliver the item is too far from the current location. So the number of items delivered may or may not be correlated with the time traveled, but yes, it is still correlated with the time traveled, because if you are delivering more number of meals, then it is not only about the distance covered and gas consumed, it is also related to the time which you will be wasting while you are interacting with that particular person. Clear? So obviously this time travel will also, the time for which you have traveled will also depend on this number of items delivered, but this time traveled is highly correlated with the distance covered and gas consumed. But apart from that, these two things, distance covered and gas consumed, are highly correlated with each other. Yes or no? So you need to identify this. And how do you identify this thing? So for that purpose, we will require some pre-processing. We require some pre-processing in order to select that what are the independent variables which should be considered for solving the regression problem. Clear? So there's it. That's for the further analysis for today's session. I'll keep it short and simple, that just by defining the error function for multiple linear regression, we can eventually define the sum of squared error, and then on partial differentiating it with respect to different coefficient, we can eventually estimate the values of different coefficients such that the error is minimized. That's the simple concept. Clear? So remaining thing will be discussed in tomorrow's session. So that will be all for this particular session. If you guys have, so I'll eventually share the problem related to this particular concept on this particular Telegram group. So you can join this group so that you will be able to access that particular problem. There's it. Tomorrow we'll discuss the concept of ridge and lasso regression. So L1 and L2 regularization. These are also known as L2 and L1 regularization respectively. So we'll try to analyze this particular concept in the tomorrow's class. Clear? So there's it. Thank you very much for joining the session. If you are new to the channel, then subscribe for the channel and press the bell icon so that you will be able to cover the complete concept of machine learning. That will be all. Thank you very much. Good night. Take care. Keep learning.